Good evening, everyone. We are from the Department of Chemical Engineering. Today, we would like to present about agitation and mixing. This is the outline of our presentation. Firstly, I will start with the introduction, and then look at the literature review. The next are methodology, findings, implications, and conclusion. Well, let's start with the introduction. Nowadays, the chemical industries use solid as a solvent in various production processes. To make a solution have an equal concentration at output is very necessary. It can be used in variety of production processes, which require stirring and mixing. So, choosing the type, size, number of propellers are essential to be considered, because all of them are the factors that affect to the result of mixing. The agitation means putting substance into the motion by shaking or stirring in one direction. That is a way in the circle to achieve mixing. And the mixing is a condition in which two or more substances are distributed into another phase. This project is study about the nature of liquid motion in the mixing tank and compare the time and energy required for stirring when using different types of impellers. The objectives of this project are to find the mixing time of water and potassium permanganate from the different types of impellers by measuring the absorbance. And the second is to calculate the power and mixing time by using the different types of impellers. The next section is about literature review, and I would like to let Mr. Sukan to talk about this.
Thank you, Patharakan. The purposes of agitation in this experiment are suspending solid particles, bending of two or more liquid types, dispersing a second liquid to form an emulsion, dispersing a gas through the liquid, and promoting heat transfer. In the chemical industries, the effects of process depend on agitation and mixing fluids. The liquids are agitated in a cylindrical vessel, which can be closed or open to the air. An impeller mounted on a shaft is driven by electric motor. The liquid motion in an agitated vessel depends on the type of impeller, the characteristics of the liquid, especially its viscosity, and the size and the proportions of the tank, buffer, and impeller. The figure on right hand shows measurements of turbine. This figure shows types of impeller. This slide shows liquid flow patterns. The first figure shows circular flow in an unbuffered stir tank. The second figure shows flow pattern produced by a radial impeller in a buffer tank. The third figure shows flow pattern produced by an axial impeller in a buffer tank. The considerations in the design of an agitated vessel are power consumption to drive impeller and mixing time. This equation shows how to find power consumption in different Reynolds number. The table shows values of constant K subscript L and K subscript T. For buffer tanks, having 4 buffers at the tank wall. The next slide is methodology. I will give stage to Mananchai.
Thank you, Sukanari course. This section is talk about chemical and equipment used in the experiment. Start with plastic cylindrical tank. It has a two type, buffer and unbuffer. 6-bed turbine. Motor. UV wick spectrophotometer. Tap water. Analytical balance. Potassium permanganate and test tube. This is animation to present procedure. First, install the propeller and machine the equipment according the standard form. Second, add water into the cylindrical tank and 6-speed motor at 25 rounds per minute. Third, add potassium permanganate 1 gram in the cylindrical tank and start timing and observe the substance motion. Next, sampling the solution every 30 seconds and stop the motor when the concentration is constant. After that, set UV wick spectrophotometer at wavelength 570 nanometer and scan water is the best solution. And the last one, measure the excitement of the sampling and record the data. You can repeat the experiment by changing the type of impeller and cylindrical tank. This is the picture we took when we made the lab. We have the 3 case study to do the experiment. Case 1 is propeller and unbuffered tank. Case 2 is 6-bed turbine and unbuffered tank. Case 3 is 6-bed turbine and buffer tank. Now, I will pass you over to Salan Manghong. Thank you.
Thank you, Mananchai. The next topic, I'm going to talk about finding. This is method for calculation of mixing time. First, calculate from the absorbance by plotting graph between absorbance at various times. The mixing time is the time that absorbance is constant. Second, from the graph is given below that require Reynolds number, type of impeller, and tank to calculate the mixing time. Third, from the equation is given for 6-bed turbine and constant is 4.3. Fourth, from eye assessment, you can see that water turn into purple color. Next is method for calculation power consumption. First, calculate from the equation is given and Kp equal Kt from table 1 for buffer tank. In case propeller, energy consumption in buffer tank and unbuffer tank are quite equal. Second, from graph is given below. This graph shows power consumption versus Reynolds number for 6-bed turbine. Next is table show calculated value of mixing time and power consumption. The next topic is implication and conclusion, and Thanjalak will talk about it. Thank you.
Thank you, Suran. Finally, I summarize our presentation. From the experiment, agitation and mixing are used for blending or dispersing substance into another phase. This experiment study about the mixing of potassium permanganate and water to observe the full phenomena and to calculate the mixing time and power consumption by using different types of tank and impeller, which are popular the unbuffered tank, 6-bed turbine with unbuffered tank and 6-bed turbine with the buffered tank. From the result, it can be concluded that first, the mixing time of using 6-bed turbine is less than using propeller because the turbine can generate flow in radial and tangential flow that allow the substance to distribute more evenly. Second, in comparison sick-bed turbine that used in different type of tank, the buffer tank took less mixing time than the unbuffered tank. Because buffer cause flow collide with buffer, this cause more turbulent flow and less mixing time. Third, using sick-bed turbine in mixing requires more power than the propeller because it requires power to allow fluid flow in two directions that is consume more power. The last, in comparison sick-bed turbine then used in different type of tank, the buffer tank requires more power than the unbuffered tank because buffer obstruct the fluid flow so more power is required to blending the substance.
That brings the presentation to the end. It was our pleasure being here. And thank you for your attention.